Okay, in this lesson, we're going to start to learn how to prove whether two triangles are congruent. We've talked a lot about what to do or how to identify the corresponding parts of congruent triangles, but we had to know that they were congruent first. Well, that's what we're going to talk about in this section of material here. How do we determine or prove that triangles are congruent? So I want to keep us in mind, remind us of a few things. Two triangles are congruent if all of their corresponding parts are congruent. They have to match perfectly. And this acronym of CPCTC, the corresponding parts of the congruent triangles are congruent. Once we know they're congruent, we know about all of their parts. We today have to figure out, are they congruent? And remember, everything is about corresponding parts and corresponding order. So this is going to be really important. The question we have to ask ourselves is, do we really have to know all of the parts? Once we know the triangles are congruent, we know all three angles are congruent and we know all three sides are congruent. But do we need to know all six parts in order to figure out that the triangles are congruent to start with? And the answer is no. We need some subset of information. There is a minimum amount of information that we need. And in fact, I'm going to show you several ways to determine if triangles are congruent, and each way only requires three pieces of information. Remember, there's six parts, three angles and three sides. In our examples, we only need three of those parts to figure out if the triangles are congruent. Once we know they're congruent, now we know that the other three parts have to be congruent. That's what CPCTC does for us. We're going to use three parts to determine that they're congruent. And then CPCTC says, now that we know they're congruent, all of their corresponding parts are congruent. So now we know the other three have to be congruent. So let's look at a couple different ways to do this. Now, the names of these are really important. The first one is called SSS, or side, side, side. S stands for side. There's nothing super tricky in this. And all this means is that if we know all three sides from one triangle are congruent to all three sides from another triangle, then those triangles have to be congruent. If you had three sticks measuring whatever, 6 inches, 10 inches, and 12 inches, there's only one triangle that you can make with those sticks. Remember, to be a triangle, the segments have to meet at their endpoints. So there's only one triangle you can make. No matter how many times you break those three sticks apart and put them back together, if your sticks measure 6 inches, 10 inches, and 12 inches, there's only one triangle that you can make. So if all three sides of one triangle are congruent to all three sides of the second triangle, those triangles have to be congruent. It's called the SSS rule, theorem of triangle congruence. Our second example, SAS. Well, S stands for side and A stands for angle. So SAS. Now, the order of these letters, excuse me, the order of these letters is really important. SAS. Look in the picture. It is the angle that sits between the two sides. So SAS. Two sides, and it's the angle sitting right there in between them. So the order of the letters matters. SAS, side, angle, side. If two sides and the angle in the middle, called the included angle, from one triangle, are congruent to two sides, side one, side two, and the included angle from a second triangle, then those triangles have to be congruent. And notice that we name them in corresponding order. So in the first one, we started at the angle BAC. So we started at our angle and went upside 2, then over. In the second triangle, we start at the angle we know, move upside 2. I'm sorry, BAC, we went upside 1. From the angle BAC, so from the angle that we know, upside 1, and then over. We're going to do the same thing in the second triangle. We're going to start at the angle we know. We're going to go upside 1, and then over. So EDF, corresponding order. Once we know the triangles are congruent, then we can say, oh yeah, well, angle F and angle C, they're the corresponding parts of the congruent triangles. So they have to be congruent. CPCTC. Our focus right now is, can we determine if the triangles are congruent? And so far we have 2 ways. SSS, side, 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 and SAS, side, angle, side. Our third rule, ASA. Again, the order of these letters tells us what it's going to look like in the picture. It's 2 angles and the side connecting them. Look at the picture. 2 angles and the side connecting them. Angle B and angle C, and then the segment connecting them, BC. When we have 2 angles and the included side from one triangle congruent to 2 angles and the included side from another triangle, then those triangles are congruent. And we can write that congruent statement. So the name ASA tells us what to look for. It also tells us where to look for it. 2 angles and the side between them. SAS, 2 sides and the angle between them. SSS, all 3 sides. The name tells us what to look for and where it will be in the picture. Let's look at our fourth one. AAS. Now again, 2 angles and a side, but it's not the included side. Remember, ASA was 2 angles and the side between them. This is 2 angles and not the side between them. Well, the problem, if you look at the picture, if our angles are angle B and angle C, there's 2 sides that are not included. So we have to make sure it's the corresponding non-included side. Notice in these pictures, side 1 is coming out of angle 1, and we can call it going to angle 3, right? C is 1, B is marked 2, we'll call A angle 3. So we have 2 angles and the side going 1 to 3. We have to match that with 2 angles and the side going 1 to 3. So FD goes 1 to 3. If 2 angles and a non-included side of one triangle are congruent to 2 angles and the corresponding non-included side of another triangle, then those 2 triangles are congruent. Has to be the corresponding non-included side, AAS. So all of these examples require 3 pieces of information, a combination of sides and angles. There's only one more, and it's called HL. Now, think about it. HL, hypotenuse leg. Only a right triangle has a hypotenuse. So even though there's only 2 letters there, HL, by definition, this has to be a right triangle. So that's the third piece. It's a right triangle. Not every right triangle is going to use HL. Not every right triangle is going to use HL. And I'll give you an example over here on the right. The picture that I just drew on the right, that could not be HL. We don't have the hypotenuse. We have a side, we have a second side, and we have the angle between them. So this one looks like SAS. Now remember, we're comparing two triangles. You can't have SAS in one triangle. I'm just showing you an example of a right triangle that would not use HL. HL means that we have a right triangle and the hypotenuse and leg are congruent to the hypotenuse leg of a second right triangle. And you can see that in the slide. If the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then those two right triangles are congruent. And we can write a corresponding congruence statement. Everything has to be corresponding order. But again, just because it's a right triangle does not mean it will be HL. It means it could be HL. If it's not a right triangle, then it can never be HL. A hypotenuse only exists in a right triangle. Right? So those are a few things that we have to sort out. Now, there's only 5 ways to determine triangles are congruent. So we want to make sure that we understand what these terms mean, and then we can start to apply them. So again, there's only 5 ways, and we're going to use it as a process of elimination. SSS for side, side, side. SAS, side, angle, side. ASA for angle, side, angle. AAS, angle, angle, side. It has to be the corresponding side. And HL, hypotenuse leg. It is a 5th option if we're working with right triangles. If we're not working with right triangles, we immediately cross it off the list, and we're down to 4. So we're going to use that as a process of elimination as we determine whether triangles are congruent. And we're going to do that in the second part of the video.